So in the last example, we looked at it where it was just x and y, right? But what if it was a binomial that had like x3, for instance? Still doable. First thing we're going to do is figure out, well, first thing we're going to do is figure out that the variables are going to go using a and b, a to the fourth, a cubed b, a squared, b squared, a, b cubed, and then b to the fourth. The coefficients we're going to get off of the triangle, so 1, 4, 6, 4, and then 1. So now it's like substituting in what the original was asking for. So in this case, everywhere there is an a, you're going to substitute in x. Everywhere there's a b, you're going to substitute in -3. So if the binomial is minus, then that negative is part of it. So -3. Once you substitute those in, you then simplify. So for instance, where it was 4x cubed -3, you multiply the 4 and the -3 to get -12. That -3 became 9. That 9 multiplies the 6 to get that 54. -3 cubed is -27 times 4 is -108. And then that -3 to the fourth is +81. So x minus 3 to the fourth is equal to x to the fourth minus 12x cubed plus 54x squared minus 108x plus 81. Again, you could just do x minus 3 times x minus 3 times x minus 3 times x minus 3. It would take you, I don't know, 10 times longer than using binomial expansion theorem. Other thing I want to point out, that the signs in your expansion, your product, whatever, are either going to be like this, right? So if the binomial that you're expanding is subtraction, the signs will alternate. You always have whatever the first one is positive, and it'll be minus, plus, minus, plus. It will alternate like that. Or if the binomial is plus, like if that was x plus 3, then they would all just be positive. So in a binomial expansion like this, either they alternate when it's minus, or they all are positive, or they're all plus if the original was addition. All right, let's take a look at the next one. So another wrinkle where what you're expanding has an exponent. Not a problem, because you're just going to use basically the exact same form that we just did. The first thing we figure out is based on it having an exponent of 5, the coefficients are going to be from the triangle 1, 5, 10, 10, 5, and 1. And then again, you pick two variables. So you could use, I mean, you could do this step with x and y or g and h, whatever you want to do. They're choosing to use a and b. So it'd be a to the fifth and then a to the fourth b, a cubed b squared, a squared b cubed, a b to the fourth and b to the fifth. So that pattern will hold no matter what. And then we're just going to substitute in for a, s squared, and in for b, 3. Once you do that, you simplify, right? So just make sure that you're using exponent rules properly, where you multiply, meaning s squared to the fifth, 2 times 5 is 10, so s to the 10th. Here you've got s to the 8th, because it's 2 times 4, then that 3 multiplies that 5, so you get 15. So here, s squared cubed, 2 times 3 is 6, so that's that s to the 6th there. 3 squared is 9, times 10 is 90. Here you've got 3 cubed, which is 27, times 10, which is 270. And then s squared squared, so 2 times 2 is 4. Here you've got 3 to the fourth, right, which is 81. That 81 times that 5 is 405. And then the last one, and then, well, the s squared stayed s squared. The last one here, 3 to the fifth, is 243. That's it. So s squared plus 3 to the fifth power is equal to all that. All right, let's take a look at the last one they want us to do here. So we're going to use binomial theorem to expand all that. Why don't you try both, come back, and then we'll compare answers. All right, so I made a triangle again. So you could use just one if you had it written on paper. So I know I have that arrow for the 6, but that's for part B. So for Part A, I'm using that bottom line with the 1, 7, 21, 35, 35, 21, 7, 1. All right, I work out the variables with A's and B's. I substitute X in for A, -1 in for B. The effect of the -1 essentially is it just alternates the positive, negative, the addition, subtraction for each term, depending on if it was a, what exponent was on the -1, right? So I ended up with x to the 7th minus 7x to the 6th plus 21x to the 5th minus 35x to the 4th plus 35x to the 4th minus 21. Oh, well, I caught a mistake. Hold on. That should be a 3. Plus 35x cubed minus 21x squared plus 7x minus 1. All right, for part B, again, I'm using that 6th line. So I work it out with the A's and B's first with the coefficients. Then I substitute 2c in for A, D in for B. Then I apply the exponents to the 2c's. Make sure that you're applying the exponent to the 2 as well. So 2 to the 6th is 64, c to the 6th. 2 to the 5th is 32 times 6 is 192. And then c to the 5th, d. Here, 2 to the 4th is 16. 16 times 15 is 240. c to the 4th, d squared. Here, 2 cubed is 8 times 20 is 160. And you've got the variables. 2 squared is 4 times 15 is 60. Here you just have 6 times 2 is 12, and then the last one has no coefficient. So you end up with 64c to the 6th plus 192c to the 5th d plus 240c to the 4th d squared plus 160c cubed d cubed plus 60c squared d to the 4th plus 12c d to the 5th plus d to the 6th. All right, it is a lot, but imagine trying to do this not using the triangle. I keep saying it for each example, but try to imagine not using the triangle, not using the expansion process. This would be impossible. Well, I guess impossible is the wrong word, but it would be horrible. I don't know. Let's say that to try to do this by hand without using this triangle. So yeah, that's a pain, but consider how much work you got done with the amount of work that you did. All right, I think it's a pretty powerful process to have, and this will come in handy as we move along in the chapter. So try the exit ticket. Reach out to me if you have questions. This is the kind of thing I think once you get the hang of it, there's no part of this process that is terribly difficult. It's just a long process, right? And then one little mistake throws the whole thing off. So just being, taking attention to detail into account is really important with this. And yeah, just practice is going to help with this. So the more you practice these, the better you're going to get at it, the more they'll make sense. Okay. Let me know if you have questions and try the exit ticket, and then we'll reconvene in class, go over the exit ticket, and then you'll try the practice. And again, reach out for me with questions, but this is a good top skill to have. So again, reach out if you have questions.